As requested, I'm going to work through a number of sample problems in preparation and to help you prepare for tomorrow's test. Some of these are more difficult than ones you'll see tomorrow, but it made it easier for me to compare, for example, equations and inequalities if I used the exact same setup. Okay, so this is called a radical equation because there's a radical in place and an equal sign. And so this one should be fairly simple. We're just going to progress one step at a time until we get to the x. We have to get rid of the 4 and the negative and the fourth root and the 2 and the negative 15. We're going to do this one step at a time, always doing the same thing to the left side of the equation that we do to the right. And we're going to typically get rid of the farthest from the x, the farthest quantity from the x. Okay, and so initially that's a positive 4. It's way over here. We're going to get rid of it by subtracting it from both sides, and that's going to leave this. So 2 minus 4 is negative 2. 4 minus 4 leaves me with just the negative fourth root. I now need to get rid of the negative sign. I do that by dividing or multiplying by negative 1. That's going to change the sign on both sides. And now it's time to get rid of the fourth root. If this were written as a rational exponent, it would be 2x minus 15 to the 1/4 power. Well, the way we get rid of it is raising it to the 4th power. So I'm going to raise both sides to the 4th power. 2 to the 4th is 16, and the fourth root is gone. Now, of course, I add 15 to both sides and divide by 2. Okay, so this is the answer. We have to be on the lookout, however, when we have problems that involve even roots, so square roots and fourth roots and sixth roots. We always have to be concerned about the possibility of an extraneous solution, so we'll need to check. We need to check to make sure that this solution is correct. And so I'm going to plug into my calculator the left side of the equation with 15.5 plugged in for the x and make sure it's equal to 2. Okay, so this is what we need to evaluate. I'm going to plug it in my calculator like this. Drum roll, please, and we'll find that the answer is indeed 2, so we are correct. I want to work an inequality that's exactly the same, except for instead of an equal sign, I have greater than 2. So we're going to proceed the same way initially. We're going to do the exact same thing. The steps are exactly the same. You will notice at this point, however, when I divided by the negative 1 or multiplied by negative 1, I did change the direction that the sign was pointing. Math is exactly the same, and we find that x is less than 15.5. Now, unlike last time, we have more than one solution. This is an infinite number of solutions, but we have an issue here. We have to make sure, since I'm taking the fourth root of 2x minus 15, I have to make sure that 2x minus 15 is greater than or equal to 0. So over here to the side, I'm going to do a second problem, add 15 to both sides, divide by 2. And so my initial, the algebra, tells me that x has to be less than 15.5. But the radicand tells me that x has to be greater than 7.5. And so my x is going to be somewhere between 7.5 and 15.5. So we write our answer like this. Let me move this off the screen. Okay. In addition, you can check this on the calculator. If you punch in the left side as y1 and the right side as y2, I had to move the window around a little bit to get a good fit. Once you do that, you can see here are the two functions. 2, which is constant, and then the one with the fourth root. Okay, we're trying to figure out when this part is greater than 2, so that's clearly up here. The part we did at the beginning tells us that anything left of 15.5 works, so anything over here works. And the second part we did told us, well, you have to be greater than 7.5 for the fourth root to exist. So this is where our answer is, and this final answer here is correct. All right, now we wish to multiply and divide rational expressions. Keep in mind here, we do not need the LCD. Also keep in mind we can't change the value of anything because we don't have an equation. All right, that being said, I have one fraction divided by another fraction. We do not like dividing by fractions, so instead I'm going to write out the first one and I'm going to multiply it by the reciprocal. And that takes us here. From this point, before I start multiplying across the top and multiplying across the bottom, I have to factor. Okay, so this is a difference of squares. The bottom we might use the t-chart for. On the right side, I might use the t-chart up top, but on the right side, it's simply a difference of squares. All right, from this point, I see that I've got x minus 1s on the top and the bottom, 2x plus 1s on the top and the bottom, and x minus 2s. So all that's left is the x plus 1 on the top, x plus 2 on the bottom, and we're done. These are really the easiest kind of problems. All right, when we add and subtract, what makes this more complicated is I can't subtract these guys without them having the same denominator. So I have to find the LCD. So both of these are fairly complicated, so I need to factor both denominators. So I'm going to start with the first one. And hopefully the first thing you'll notice is that there's a 3 involved. So I'm going to factor out that 3. And now we've got a difference of squares, but I don't like this because the z squared is negative, the 1's positive. If I pull out a negative sign, it's going to flip it around. I'm going to like it better. Okay, so once I've done that, z squared minus 1 is the difference of squares. It's z plus 1 times z minus 1, and that's that. So that's the first one factored. Now we're going to factor the second one, and you're probably going to want to use a t-chart for that, or maybe you can just figure it out. You know the first terms are z. All the signs are positive, so both of these are going to be positive. I need two numbers that multiply to 4 and add to 5. 1 times 4. So that's the second one. So for the LCD, I need a negative 3, a z plus 1, a z minus 1, and also a z plus 4. So a fairly large LCD right here. Okay, and now we're going to update this problem. This first guy, it has a negative 3, a z plus 1, and a z minus 1. It does not have a z plus 4. So I'm going to rewrite this. I'm going to need to do it with a z plus 4. Oh, okay, I'm sorry. The first thing I want to do is factor them. And here it's really easy to see that I'm missing from the LCD. I'm actually going to cover these guys back up. I don't need to see them anymore since I've got them factored. He's got everything he needs except for the z plus 4. So I'm going to rewrite that first term. It's going to be awfully long with a z plus 4 on the top and the bottom. This other guy is missing the negative 3 and the z minus 1. So I'm going to rewrite him with the negative 3 on the top and the bottom and a z minus 1 on the top and the bottom. Okay, at this point we have the denominator is going to be the LCD. Everybody's there. And then I've distributed the 4. That's 4z minus, plus 16. And then the minus sign. And I've distributed 2 times negative 3 is negative 6. And I distributed that with the z minus 1. Now I just need to collect my z's. 4z minus negative 6z is positive 10z. And then 16 minus 6 is positive 10. Okay, I'd like to say we're done, but we're not quite. You'll notice on top I can factor out the 10, so I did that. And then I've got a z plus 1 on the top and the bottom, so I'm going to slash that out and cancel it. And we're left with this beauty right here. I don't know that we'll have one this difficult tomorrow, but if you can understand this one, you'll be set. Okay, 3 more problems. So I want to solve a rational equation. This time I have an equation, so I can change values as long as I do it to both sides. Before I do anything else, I'm going to find the LCD. And I mean literally find it. I'm not sure where I put it. Here we go. Okay, to do that, I'm going to factor the largest one. It's x minus 3 times x plus 1. You could use the t-chart to do that. And you'll notice that both of these other guys show up in the LCD, so I can stop right there. No need to do anything else. That's their LCD. We're also going to find the excluded values, and they're the values that make the LCD 0. So positive 3 or negative 1 are just against the rules. Okay, that being said, I'm going to multiply everybody by the LCD. Okay, and so I did a shortcut here. If I multiply the first guy by the LCD, the denominator disappears. You're left with 4. If I multiply the second term by the LCD, the x minus 3's cancel, and you're left with an x and an x plus 1. And then finally, if I multiply this guy, well, first there's the negative. If I multiply this guy by the LCD, the x plus 1's cancel, and I'm left with a 1 and an x minus 3. Now we just have to clean up. So I'm going to distribute the x and distribute the negative 1. And then x plus x is 0, so I'm going to move that out. And now I'm going to subtract 3 from both sides and take the square root. So x is positive 1 or negative 1. But what is that? Negative 1 is one of our excluded values, and therefore the only answer is going to be x equals 1. So we're going to mark through negative 1, and our answer is just x equals 1. Okay, I had some formatting issues over here, so thus the ugly black box. Okay, you'll notice this problem is exactly the same as the other one, except for we have an inequality instead of an equality. We'll still find the LCD. We'll still multiply by the LCD, so a lot of this process is exactly the same. Oh, also the excluded values are important. And we're going to solve this exactly the same way, the exact same steps and everything, except to right here. What's important here is not so much, you could write the answer with inequality signs, but I'm really just interested in the values of x that show up here, okay? So 1 and negative 1, if this were an equation, 1 and negative 1. So these are all the important ones. That being said, when we have an inequality, we're going to have to create a number line, and the numbers on the line are going to be the excluded values and any of these answers that we get from doing the algebra. So let's look at this line here that I've created. It's got negative 1 and 1, the possible answers, and negative 1 and positive 3, the excluded values. I'm going to pick values in between them, and then I'm going to test one after the other using my calculator to see which ones work. In this case, only one of the sections worked, number 2 worked, and so that's probably my answer right there. So I've written that. It's all the x's between 1 and 3. Okay. Finally, there's one other thing. If you feel if you don't feel very confident, you can always plug this into your calculator as y1 and this into your calculator as y2. I've done that, and I also changed the window a little bit, and this is what we see. To get all this out of the way. Okay, so the right side of the equation is the dark one, and the thin line is the left side of the equation. So I want to know when the thin line's above the dark line, and that's only true right here. It starts at x equals 1, and then it goes all the way to the asymptote at x equals 3. So we're correct. The answer is between 1 and 3. All right, and then finally, graphing a function. To do this, the first thing we're going to need to do is factor. So t-chart is the situation you're going to use here. Okay, and this is what we get. On the top, I have x minus 7 and x plus 2. The bottom, x plus 4 and x plus 2. I hope you'll notice that the x plus 2's cancel. But if we cancel them, we're going to need to remember that x cannot be equal to negative 2. That's against the rules. Okay, so once you've factored and you've simplified, what you need to do is account for any point discontinuities or vertical asymptotes. Since we marked out the x plus 2, we have the same factor on the top and the bottom. That's a point discontinuity. Okay, so we have a point discontinuity, and it begins where x is negative 2. To find the y value here, you simply plug it in to the updated equation. Negative 2 minus 7 is negative 9, and negative 2 plus 4 is positive 2. So the answer should be negative 9 over positive 2. Okay. There's a point discontinuity, and I can look here. I have a vertical asymptote where a factor's on the bottom, but not the top. Negative 4 would mess this thing up, so that's where my vertical asymptote is. All right, now that we've got these two, we're going to graph them, but we're also interested in other points. So I'm just going to reveal most of this right now. Okay, so our point discontinuity is right here. I used an open circle. The vertical asymptote is this dotted line right here. I chose some x values. I made a table of values here so that we could get a better sense of what this function does in addition to the two discontinuities. So I chose negative 2 and negative 3. I'm sorry, negative 5 and negative 3 because they're on either side of the asymptote. And then I chose a slightly more positive value and a slightly more negative value. Once you plot those, you just connect the dots. Moving from here to here, we're going to have to go right through there, and then it shoots down to negative infinity. And then right here, it's going to approach that line right there. From here, as I approach here, it's obviously going up to infinity, and then this is going to go down to 0, I believe. You can punch this in the calculator if you want to verify it. Just be careful to put the top and the bottom in parentheses. And I know it seems ridiculous, but if you were to put the factored one in there, you would need to do it with an extra set down there. And if you're going to do this one, the top and the bottom would need to be in parentheses. All of these should appear to be the same graph on the TI-83.